In our previous class, we have discussed about the preparation of amines along with different name reactions. In this part, we will start with the characteristics or physical properties of amines along with other forms of reactions. So first, let us start with the physical properties. Physical properties of amines. So when we start the physical properties, at first we need to understand that amines, which are mainly primary and secondary amines, they have higher boiling points than other organic compounds. Okay. So we will say that primary and secondary amines have higher boiling points. So primary and secondary amines have higher boiling points than other organic compounds of similar molecular weight because of hydrogen bonding. Okay, because they have hydrogen bonding in, just like ammonia. And what about tertiary amines? Tertiary amines do not have the property by virtue of it can show hydrogen bonding. Okay, so tertiary amines does not show hydrogen bond. Tertiary amines do not show hydrogen bond. Okay.
Yes, sir.
Next. Lower amines are gases and liquids, but higher amines are solids. Lower amines are gases and liquids, whereas higher amines are solids. Okay. Now, primary or secondary amines are soluble in water. Primary and secondary amines, 1 degree and 2 degree amines, are soluble in water because of hydrogen bonding. Okay. Even 3 degree 3 degree amines also are also means, like if they have a small alkyl chain like triethylamine or trimethylamine, triethyl and trimethylamines okay, which are 3 degree amines, are also soluble in water. Soluble in water. Actually, water has also the ability to form hydrogen bond, and the hydrogen in water forms a hydrogen bond with this trialkylamine. So let us see how this hydrogen bond formation takes place in water. If I have a 1 degree alkyl group like RNH2, okay, so this is R, this is NH. So let me draw it in a more creative way. R, N, H3, NH2. So here is a lone pair. And when we are talking about R2NH, R N, R, H, and here will be the lone pair. And when we are talking about R3N, so here will be the lone pair. Now, this lone pair will be attached to the hydrogen of another water molecule, okay, to hydrogen bond. Understand? This will be attached to
Yes, sir.
hydrogen of another hydrogen bond. Now, this hydrogen will be attached to a lone pair of oxygen of another water molecule. Okay, lone pair of oxygen of another water molecule. But here, no such hydrogen bonding will take place. So in these two cases, sorry, here is another hydrogen bonding. So we can see in 1 degree amine, we have 3 hydrogen bonds. In 2 degree amines, you have 2 hydrogen bonds. And in 3 degree amines, you have only 1 hydrogen bond. Okay, so inside water. So this affects the basicity of amines inside water. So basicity of amines inside water. Okay, means in aqueous state, how does the basicity of amines depends? Inside water means when we are talking about the aqueous medium, actually basicity depends on 3 factors. At first, the hydrogen bonding, second, the means what do you say? Mm, mm, the nature of the alkyl group, sorry, the length of the alkyl group. Okay. And third, the degree of the alkyl groups, the degree of the amine. The degree of the amine. For example, if I have CH3NH2, okay, if I have CH3NH2, CH3 whole twice NH, CH3 whole 3 N, then the basicity order would be length of the alkyl group and its plus I effect. Okay. Actually, the length of the alkyl group and plus I effect doesn't go side by side, but higher the plus I effect, higher will be the solubility. It also does not go like that. So length of the alkyl group is a main thing, main interesting part, that the length should not be high, because with the higher length, it will be the hydrophobic end will be much higher and solubility in water will be less. Okay. So in this case, the secondary amine will have 2 plus I effects and 2 hydrogen bonding. Okay, 2 plus I effects and 2 hydrogen bonding. Just see here, it has 2 R groups. That means they can show 2 plus I effects. Here it can show only 1 plus I effect. Here it will show 2 plus I effects. And here it will show 3 plus I effects. Okay, electron donating effects. So with the increase in electron density over nitrogen, this hydrogen bond with this lone pair of nitrogen, the strength increases. Okay, the hydrogen bond strength with the lone pair of nitrogen increases. So moderation, this 2 degree amine means CH3 whole twice NH will show the highest basicity in water. Okay, basicity order in water. Then it will be either 1 degree or 3 degree. In this case, CH3 does not have much plus I effect. So CH3 whole 3 N will win in this part. Sorry, CH3 whole 3 N trialkyl amine, trimethylamine will win, and followed by CH3, sorry, CH3NH2 will win. CH3NH2 will win, followed by CH3 whole 3 N, because plus I effect of the methyl group is not much high. Okay, so hydrogen bond strength will supersede here the plus I effect. But if it was C2H5NH2, ethylamine, C2H5 whole twice NH, C2H5 whole thrice N. Okay, then you would have seen the basicity order in water. Basicity order in water. At first, the secondary amine will come because of 2 plus I effect and 2 hydrogen bond, and sorry, 1 hydrogen bond, followed by this 3-degree amine, C2H5 whole thrice N. Because here, plus I effect of the ethyl group is much more dominant over the hydrogen bonding interactions. Okay, means it is increasing the strength of hydrogen bond to a higher extent, followed by C2H5 and H2. Okay, so this is the basicity. In gaseous phase, we have already discussed in the gaseous phase. Basicity in gaseous phase, we have discussed in our previous class also. In gaseous phase, as in gaseous phase, no hydrogen bond interaction actually occurs. So we will say that 3-degree amines will have the highest basicity, followed by 2-degree amines and primary amine over ammonia. Okay, but we cannot say the same in aqueous medium because there will be some hydrogen bonding interaction in aqueous medium. Next, the solvation effect in amines are also quite appreciable. Means if I have like C4H9 NH2, then I have C3H7 NH2, then if I have C2H5 NH2, so we will say the basicity order will be like this. Okay, the 2-degree amine will be of higher basicity than this and this. Okay, if it is N-propyl, okay, this should be N-propyl. So this will be the basicity order. Because your solvation effect decreases with the increase in hydrophobic chain. So as the hydrophobic chain increases, solvation in aqueous medium decreases. So we will say that this N-propyl and aniline or N-butyl amine are of lower solubility or lower basic strength than ethylamine. Okay, like that we can say. Now let us come to the reaction part. Okay, let's come to the reaction part. Just a minute. So when we're talking about the reactions, we will be basically mentioning the 1-degree amines. Okay, we will basically understand the reaction of 1-degree amines. Then we will go about the distinction between 1-degree, 2-degree, and 3-degree amines. But first, we will only learn about the reactions of 1-degree amine. So in 1-degree amine, you have an alkyl group added to an added to an NH2 group. Okay, an alkyl group added to an attached to a NH2 group. So what does this NH2 group stands for? It stands for the basic nature of this molecule. So if you add an acid like HCl, so it will form RNH3 plus Cl minus, it will form a salt. Okay, if you add HCl to it. Now, if you want to add like the Hofmann's ammonolysis part, we have already mentioned. If you want to add the R dashed, a different alkyl group, X, then it will give you RNH, R dashed plus XH. Okay, so if you want to continue it, continue adding R dashed H, then it will give first the tertiary amine, then the quaternary ammonium salt, just like Hofmann. This is a Hofmann ammolysis method. Okay. The third one is if you want to react it with any sort of means any good living group, like if I have like this is it is attacking this through backside. So if I also give something like RCOCl, okay, RCOCl or acetic anhydride type, C double bond O, C double bond O R like this. So it will form. So give R dashed R NH C double bond O R dash. So this will be an alkyl amide. Okay, an alkyl amide. Okay, it will give rise to an N-alkyl amide. This R dash can be anything in alkyl amide. The next thing is any other type like a tosyl chloride. If I want to react it with a tosyl chloride, this is S double bond O Cl. Okay, this is known as tosyl chloride given by TSCl. Okay, tosyl chloride TSCl, paratoluene sulfonine chloride. So here also you will see that it is attacking here and this is going out. Okay, these reactions are carried out in DCM medium, means it is the solvent used here is DCM. Okay, DCM means dichloromethane, CH2Cl2. So you will get RNH as double bond O CH3. Okay, so this is the thing that it will get. So this is also used for separation, means the distinction between 1 degree, 2 degree and 3 degree Amines. I will come to it in just a little bit. Then if I have to prepare alcohols, remember in our previous class I have mentioned to prepare alcohol from amine, I just have to use HNO2 or the diazo reaction medium NNO2HCl. Okay, and I will get ROH. The reaction is typically like this, RNH2, and here is N double bond OH, and you can simply think of this N2 and water. So the byproducts are here N2 and water. Okay, these are the byproducts. Alcohol, these are the byproducts. So this is it. Next, the main important reaction is our carbylamine reaction. Okay. So it's carbylamine reaction. So in carbylamine reaction, what we use this RNH2, then we use chloroform CHCl3 followed by alcoholic KOH. Okay, followed by alcoholic KOH, and from here we will get the isocyanide. Okay, from here we will get the isocyanide. The Bhopal gas tragedy, Bhopal gas tragedy reaction, methyl formation of methyl cyanide. So this is one of the example of this methyl cyanide formation. So this is known as carbylamine reaction. Okay, this is also a distinction. Sorry, this is also a very important reaction to remember because it will help you to distinguish between 1 degree amine, 2 degree amine, and 3 degree amine. 1 degree amine only gives this isocyanide reaction or carbylamine reaction, but 2 degree amines and 3 degree amines does not give this reaction. Why? Because they do not have two hydrogens here. So here we will start with the distinction of primary, secondary. Means we have to differentiate between 1 degree, 2 degree, and 3 degree amines. 1 degree, 2 degree, and 3 degree amines with chemical reaction. Okay, we have to distinguish between 1 degree, 2 degree, and 3 degree amines with chemical reactions. Now, what will be the first reaction? So the very first reaction will be our reaction with nitrous acid. RNH2, R2NH, and R3N. So if I add HNO2 here, I will get an alcohol, okay, with the effervescence of nitrogen. Okay, the reaction will give alcohol with the effervescence of nitrogen. But in this case, I will not get the effervescence of nitrogen. On contrary, I will get R2N N double bond O. So you can ask me how that I am getting this. Actually, in HNO2, if you get HNO2, this is OH and double bond O, HNO2. So this H and this OH will form water and you will get this R2N double bond. This is nitrosoamine. This is known as nitrosoamine. Okay. And this is also known as Libermanns nitrosoamine test. Okay. Libermanns nitrosoamine test. Okay, we will get this one. And if you use HNO2 here, you will get R3NH plus ONO minus. Okay, so it will form a salt. Okay, and you will get this only. So no reaction. So this is the first distinguish when you are differentiating them. So you are using HNO2 to distinguish between 1 degree, 2 degree, and 3 degree. In the second test, we will use benzyl sulfonyl chloride. Okay, the thing that we have used tosyl chloride in place of tosyl chloride, we will use only benzene sulfonyl chloride. Okay, so we will use benzene sulfonyl chloride. I will write it down. I will use RNH2 plus this is benzene sulfonyl chloride. The same thing, but does not have the CH3 at the bottom. This is known as benzene sulfonyl chloride. Okay, so here you will get RNH S double bond O benzene. Okay, so this is known as N-alkyl benzyl sulfonamide. This is N-alkyl benzene sulfonamide. The names are very important. Okay, the names of these reactions are very important. Now, if you add here KOH, okay, if you add here aqueous KOH, then you will see that this becomes soluble. Okay, this becomes soluble because this NH will move out and you will get a salt. Okay, it will do a soluble salt here. It is Rn minus K plus S double bond O benzene. Okay, this is a soluble salt. So for 1 degree amine will form a soluble salt. But what will happen to a 2 degree amine? So R2NH, the same thing. I'm writing PHSO2Cl. Okay, SO2Cl. So here R2N S double bond O benzene ring. Okay, but if you add here aqueous KOH, you will not get any soluble salt. Okay, so it will be insoluble. In aqueous KOH, it is insoluble, and this reaction, there will be no reaction in this case. No reaction. So when we are using this pH SO2Cl, this is known as Hinsberg reagent. Okay, so this sulfonyl chloride is known as Hinsberg reagent. Okay, and this test is known as, these tests are known as Hinsberg's test. Okay, these tests are known as Hinsberg's test. Tests. Okay. So two tests we have already mentioned. Test number 3 to distinguish between them is carbylamine test. This is only for our 1 degree amine. We have already mentioned RNH2 with CHCl3 and alcoholic KOH. Okay, will give you isocyanate. Okay, so it has a characteristic unpleasant odor. Odor. Okay, it has a characteristic unpleasant odor, and 2 degree amines and 3 degree amines does not give this test. Okay, these two does not give this test. The final distinguish is known as Hofmann's mustard oil reaction. Fourth one is Hofmann's mustard oil reaction. Here we will use RNH2, CS2 and HgCl2. Okay, mercury chloride, CS2 and mercury chloride. So it will form N substituted M, sorry, R, N, double bond C, double bond S. Okay, this will form N substituted isothiocyanate. Okay, N substituted isothiocyanate. Okay, this point is known as isothiocyanate. Okay, CnCS is one and SCN is another one, which is known as thiocyanate. SCN is thiocyanate when some alkyl group will be attached to S and single bond to C and triple bond to N. That will be thiocyanate. And when the alkyl group is attached to N and it is double bonded to C and which is double bonded to S, this structure is known as isothiocyanate. Okay, so structurally, these two are, you can say these two are like the tautomeric forms, but it is thiocyanate, which that was thiocyanate, and this is isothiocyanate. Okay, but similarly, like carbylamine reaction, here also the R2NH and R3N will not give any reaction. Okay, will not give any reaction with CS2 and HgCl2. So they are unreactive towards this mustard oil reagent, Hofmann's mustard oil reaction. Why it is known as mustard oil? Because it smells like an mustard oil. Okay, it has a very means what do you say, a very crispy and a very unpleasant mustard oil like smell. Okay, so this is the thing we have discussed about the properties and the basic reactions of all the amines, mainly primary amines and some secondary amines for distinguishing. There are other reaction as well of this part. So some other reactions that are mostly we discuss here is the reactions like carbonyl and amines, carbonyls and amines. Okay, specifically primary amines. So what type of other reactions? If you have a ketone or an aldehyde, anything, and if you add this, so you will get RCH or R dashed, double bond N, R double dashed. So this is the reaction that we have studied in our carbonyls chapter, means aldehyde ketones and carboxylic acid chapter. In this part, we could also say that it will undergo this type of reaction. Some other reactions are are important as well, like they can undergo different forms. Like this R dash can be a lot of things. It can be another NH2. This can be like an OH, which will make it an hydroxylamine. So different forms of reactions are there, in which we can say that this amines will react with this carbonyl compounds. And if you want to understand about some other reaction as well, yes, there are some other reactions like this type of amines. Primary amines are they can readily undergo nucleophilic aromatic substitution reactions if there is a strong electron withdrawing group attached to a benzene ring, so like NO2 group. So we will discuss it in our next classes. So